This video is about finding molality, and we've been still talking about concentration. Molality is a measure of concentration, but it's a little bit different than molarity. Molality is lowercase m, and it's moles of solute divided by kilograms of solvent. And in our T table, we have lowercase m molality, which is moles divided by kilograms. Okay, so let's take a second. Let's talk about the difference between molarity and molality. We're pretty familiar with molarity. Molarity is a measure of concentration, but it takes moles of solute and it divides it per liter of solution. And the word solution there is really important because the solution is the total. It's the solute and the solvent added together. And that gives us capital M molarity. Molality is a little bit different. Molality is what we use more often when we're talking about adding salt to water that's already in a beaker. Molality, or lowercase m, is moles of solute again, but this time it's divided by kilograms of solvent. So that notice that it's just the solvent. Molarity has the whole thing, the solution. Molality is just the solvent. And usually our solvent is water. Now, water is often measured in the lab in milliliters, but we need to know a conversion. We know that 1 milliliter of water equals 1 gram of water. So if I have 400 milliliters of water, I have 400 grams of water. If I have 1,000 milliliters of water, I have 1,000 grams of water. It's a 1-to-1 ratio. So if I have grams, I have to turn it into kilograms in order to put it into my equation. And I know that 1,000 grams equals 1 kilogram. So if I divide my grams by 1,000, I'll get kilograms. That's the difference between molarity and molality. Molarity is the whole solution. It's measured per liter. Molality is just the solvent. It's measured per kilogram. Okay, so let's look at a couple of problems. We're going to be working in your notebook, Interactive Notebook page 6, and on Interactive Notebook page 6 we have a worksheet called Concentration Practice Problems. We're going to be looking at the problems on the back of that worksheet, and we're going to be looking in the first section, molality, and we're going to be looking at problems A and B. So let's go back and look at those problems and practice molality. Okay, so remember that we have to have solute and solvent. Let's take a second and talk about what solute and solvent is. A solute is the thing going into the solvent. It is being dissolved. It's usually the smaller amount, and it's like a salt. If we were going to put salt in water, the solute would be the salt because it's being dissolved. The solvent is the thing that is doing the dissolving. It's the thing that it's going into. It usually is the larger amount. So in a case of salt water, the salt would be going into the water, so the water would be the solvent. Water is the universal solvent. Okay, water is the universal solvent. So in most cases, if you're looking at a problem and it's talking about something going into water, water will be the solvent. So let's read the problem and let's try to identify what's our solute and what's our solvent so that we can tackle the equation. Okay, our problem says how many grams of KCl must be dissolved in 255 grams of water to prepare a 0.44 molal, or little m, solution. Okay, so I need to read this and I see what is going into what. Well, I know that KCl is being dissolved. What must be dissolved? If it's being dissolved, it must be the solute, and it's going into water. So water must be the solvent. That's going to help me determine where the values go in my equation. Okay, so I'm going to use my little T table, and I know that molality, or lowercase m, is moles of solute divided by kilograms of solvent. So I need to know how many grams of KCl, or solute. Well, solute is going to be on the top of my equation table. Now I have moles written here and I want grams, so I know I'm going to have to do a conversion at the end, but I'll start by getting moles. In order to get moles, I'm going to take molality times kilograms of solvent. Well, I know that my water is my solvent, so let's plug in the numbers based on what we have in our equation and let's see what we get. So I'm going to take molality times the kilograms. Well, the molality from my problem is 0.445 molality times kilograms. Well, I have 255 grams of solvent. Can I turn grams into kilograms? Yes. In order to turn grams into kilograms, I'm going to divide by 1,000. So 255 divided by 1,000 is going to give me 0.255 kilograms. Now I just want us to remind ourselves of something. Molality means moles per kilogram. So the kilograms are going to cancel, leaving me with moles. So I'll be left with moles. So I need to plug this into the equation. 0.255 0.445 times 0.255 is going to give me 0.11. So 0.11 moles is how many moles I'm going to need, moles of solvent. My problem, though, asked me for grams of solvent. Well, I'm sorry, grams of solute. I need to know how many moles of solute I have. So I have 0.11 moles of KCl, and I need to turn it into grams. Well, that's just going to be a moles to grams conversion. I know that moles comes down, and I can convert to grams by using the mass on the periodic table. K has a mass, looking at our periodic table, of 39.08 plus Cl, which is 35.45, and I get a mass of 74.53. And again, I got that by adding up the mass of K and Cl from the periodic table. So 74.53 times 0.11 is 8.19, or we're going to say 8.2. 8.2 grams of KCl. And that is my answer, because I wanted to know how many grams of solute, or KCl, must be dissolved in 255 grams of water to prepare a solution. And remember, I knew that solute was the thing that was going to be dissolved into my solvent or water. So I know that solute would be here and solvent would be there. Okay, one more problem. We're going to look at problem B. Problem B says, what is the molality, so I'm going to be looking for molality, or lowercase m, of a solution prepared by dissolving 35.2 grams of KCl in 300 milliliters of water. Still using my use of the definitions, I know that this is going into this. So this must be my solute. This must be my solvent. Well, my solute must be in moles. It's not there yet. My solvent must be in kilograms. Not there yet. So I'm going to have to do a little bit of work. So I use my table, and I know that molality equals moles and kilograms. And now I'm going to take that information and I'm going to use what I have in the problem. Okay, in order to get molality, it's going to be moles divided by kilograms. Moles divided by kilograms. And that's moles of solute divided by kilograms of solvent. Well, I've been given 35.2 grams of KCl. Can I turn that into moles? Yes. So I'm going to do that calculation right here. I'm going to take 35.2 grams of KCl. I'm going to turn it into moles. Well, if grams of KCl is on the top, it's going to drop to the bottom, and moles of KCl is going to be on top. Well, 1 mole equals the formula mass on the periodic table. So I'm going to take K plus Cl. When I add those together, I get 74.53. So now I'm going to need to divide 35.2 by 74.5. So I have 35.2 divided by 74.5. When I divide the two, I get 0.47 moles of solute, or of KCl. So that's going to go here on the top now. 0.47 moles. Now I have to divide this by my solvent. Well, my solvent says that I have 300 milliliters, so I have to think about that. 300 milliliters. Well, I know, based on the density of water, that 300 milliliters of water equals 300 grams of water. Can I take 300 grams and turn it into kilograms? Yeah, really easily. 300 grams divided by 1,000 equals 0.3 kilograms. So, for kilograms of solvent, I have 0.3 kilograms. So now I'm going to take 0.47 divided by 0.3, 0.47 divided by 0.3, and I get an answer of 1.5666, so I'm going to say 1.57 lowercase m, or molal solution. Okay, remember with molality, the key is that you have to know what is your solute and what is your solvent. Your solute is going to be the thing that is going to be dissolved. Your solvent is the thing that is doing the dissolving. It is usually water. Your solvent must be in kilograms. Your solute must be in moles. So once we have identified the solute and the solvent in the problem, we make sure they're in the correct unit. We put them into our T-table and we get our answer. That is how you find molality, a measure of concentration.